Happy Friday, Mr. Boothman here. It is College Friday. So like last week, I said we're going to start every Friday. I'm just going to share any thoughts, any wisdom I might have about college. I know for some of you this is probably the last thing on your mind right now, given current state of things, but I think, you're still going to college. I think it's something off in the horizon that gives you reason to have hope and something to look forward to right now. So we are continuing College Friday. I want to start today with probably my single best piece of advice for those of you going off to college in the fall. And that is to get involved in something. It doesn't matter what it is. I don't care if it's a club, if it's a sport, if it's getting involved in your religion, if it's starting a club, if it's going to your department's events, or joining theater, or picking up an instrument or something. But getting involved right at the start of college means that you're going to be around people with similar interests. And oftentimes that's how you're going to make your closest, longest lasting friends. College classes aren't like high school classes. Okay, very rarely do you have a professor who has you do icebreakers. And usually you aren't in class with people that you've known your whole life. So how are you going to make friends? How are you going to meet people? Are you going to put yourself out there and turn to the person sitting next to you in this 300-person lecture hall and introduce yourself? Some people do. I never did. So how do you make friends in college? I mean, it seems like a stupid question, but it's a hard lesson to learn. And my answer to you is to get involved. That's how you meet people that, like I said, you share interests with, you have something in common, and that's a good starting point. Okay. So we'll jump into our lesson from there. Good morning, happy Friday. Don't forget that today you do have a graded exit ticket that's on section 8.2. That will be due by midnight tonight. I'll be looking at those tomorrow morning, so make sure to get that done. As always, we're reviewing for this learning target for this exit ticket, so it's kind of a review day. I have a bunch of problems here. Work through each problem yourself, and then come back to this video or check the answer key that I posted this morning and check your work. Okay. Let's start with this, because I anticipate that this will be one of the biggest challenges for some of us on this exit ticket for this learning target. Write the following in sigma notation. So we have this series, and we're asked to write this using our simplified sigma notation. Okay. Now, the trick to these types of problems, the key to remember here, is how is the term number used to determine the term value? Okay. Beyond that, are there any things in common with every single term? Okay. Now, it's a series, so we're adding all of these terms together. So we are using sigma, and we're using the variable k just because of convention. Okay. And what are we starting with here? Well, to determine what value of k we're starting with, that kind of depends on what our general terms end up being. So is there anything that all of these terms have in common? All of their numerators have a 1. So no matter which term we're dealing with, we have 1 over something. Looking at the denominators, 1, 4, 9, 16, hopefully some of us recognize those as the perfect squares. Okay. When we're writing in sigma notation, looking for perfect squares, perfect cubes, things of that nature are going to be incredibly helpful to us. So here we have 1 squared, 4 is 2 squared, 9 is 3 squared, 4 squared, and so on. So how is the term number helping us determine the term value? The first term the denominator is 1 squared. The second term, the denominator is 2 squared. The third term, 3 squared, and so on. So to me, it looks like our denominator is always whatever our term number is squared. And we're starting with k equals 1. And this is an infinite series, which means this continues all the way to infinity. So this is our sigma notation shortcut for writing out this infinite series. So that can be weird. It's just very different notation than most of what you're used to. That's okay. Okay, this will be for a highly proficient score, but I want you to start to get more familiar with this kind of notation, using subscripts, using this sigma. Okay, those of you going on to any kind of higher math will encounter this much more frequently. Okay, and again, check your answers with the answer key. Let's move on with a few more practice problems. For the sequence 3, -1, -5, and so on, find the sum of the first 10 terms. So this is not an infinite sum. This is the sum of the first 10 terms. That's the 10th partial sum, so S10. And what kind of sequence is this? 3, -1, -5. Are we multiplying to get to the next term, or are we adding or subtracting to get to the next term? Well, looks like we're subtracting 4. So this is an arithmetic sequence. A1 equals 3, D equals -4. So the nth term is A1 plus n minus 1 times D. For the nth partial sum of an arithmetic sequence, we're looking at n times A1 plus AN all over 2. In this case, for the 10th partial sum, n is 10. The first term is 3, and then we need the 10th term here. Since we have the nth term formula, we can pretty easily find the 10th term. We have 3 plus 10 minus 1 times -4. 9 times -4 is -36, plus 3 is -33. So our 10th partial sum, 10 divided by 2 is just 5, times 3 plus -33, which is -150. Now, of course, you can check your calculations with a calculator, and it's totally fine. But here we are. So does it make sense that this partial sum is negative? Well, most of this sequence then ends up being negative numbers. So it does make some sense, hopefully, that when we add all of those together, we'll end up with a negative number. Again, check your work. For this series, well, sequence, 3, 9, 27, and so on, find the 9th partial sum. Okay, so we're looking for S9. Are we multiplying or adding to get to the next term? Looks to me like we're multiplying by 3. That makes this a geometric sequence. That means A1 is 3 and R equals 3. That means the nth term is 3 times 3 to the n minus 1 power. Now, for the partial sum formula of a geometric sequence, okay, that looks like this. There is no need to find, in this case, the 9th term. That's only for the arithmetic sequence partial sum formula. Okay. But it doesn't hurt that we wrote this out. Okay. We know A1 is 3. We know R is 3. And N in this case is 9. And go ahead, plug this into a calculator. Just be very careful you're grouping things with your parentheses properly. And we should get 29,523. Okay, this is the 9th partial sum of this sequence. Again, check your work. A couple more practice problems for today. help you prepare for that exit ticket. Find the sum. 4 plus 4 over 7 plus 4 over 49. Okay, 3 dots at the end. This continues forever. What kind of sequence is this? Are we multiplying to get to the next term, or are we adding or subtracting to get to the next term? 4, I mean, we could argue we're subtracting something, but does that work for the next set of terms? No. So let's come back. 4 times what is 4 over 7? And then 4 over 7 times 1 over 7, does that get us to 4 over 49? Yes, it does. This continues forever. So here, we're dealing with an infinite geometric series. When we have an infinite geometric series, okay, this will equal a nice, simple, finite number if the absolute value of our common ratio is less than 1. In this case, r is 1 over 7. So the absolute value of 1 over 7 is 1 over 7, which is less than 1. So this will sum to a finite number. What number is that? The sum of an infinite geometric series is a1 over 1 minus r. a1 is 4, and again, r is 1/7. This is 4 over 6 over 7, which is 28 over 6, which is 14 over 3. So this infinite geometric series will equal 14 over 3. Again, I know how strange using the word equal there is. An infinite series of numbers will add up and equal an actual value. Again, that's one of my favorite concepts, one of the things I love most about teaching calculus, so I look forward to discussing that more with you next year. Okay, 14 over 3. Go through your work again if you need to. And I believe we have one more practice problem for today. Prepare you for that exit ticket. Find the sum of the infinite geometric series 3 plus -6 plus 12, and so on. We're told this is an infinite geometric series. Okay, so what are we multiplying by to get to the next term? 3 times what is -6? -2. And then -6 times -2 gives us +12. So r equals -2, and we need to check the absolute value of r. Absolute value of -2 is 2. That is not less than 1, at least in most of the math that I've studied. So since the absolute value of r is not less than 1, in calculus we have a special term for this, but here we just say that this does not equal anything, okay? This doesn't exist, this sum of this infinite geometric series. You can just put an A, you can put impossible, or the sum doesn't equal anything. However you'd like to phrase that, I just think NA is probably the easiest, okay? All right, once you've gone through these practice problems, you've checked your work, you've asked me any questions you might have, then please take that 8.2 exit ticket by midnight tonight. Do your best, don't give up, and I'll look at those over the weekend, put those in the gradebook. Looking ahead to next week, Monday we will review Unit 8. It was only 2 sections, and then Tuesday we'll take this brief exam. Okay, so be ready, start reviewing. Let me know if you have any questions. I'll see you next week. All right, well, you've heard a lot from me, Mr. Boothman, today. We're not going to see Booth Dog for a while, I'll just tell you that. Have a great weekend, and I'll see you on Monday.